It takes over 200 trucks to move. It has the power to lift a massive industrial reactor or wind turbine nacelle clean off the ground. This isn't science fiction. This is the power of the super heavy crawler crane, the king of the megaproject. Today, the three most powerful crawler cranes on Earth all share one surprising fact. They're all built in China. We'll count down these titans, but more importantly, we'll uncover the industrial strategy that gave one nation total dominance, and reveal how that power is now being used to rewrite the rules of global construction. Before we can understand the why, we need to appreciate the sheer scale of the what. These machines operate in a realm where lifting capacity isn't measured in pounds, but in thousands of tons. Coming in at number 3 is the Sany SCC36000TM. This twin-boom crawler crane is a masterclass in specialized power. Its maximum lifting capacity is a staggering 3,600 metric tons, which translates to nearly 3,968 US tons. To put that in perspective, that's the equivalent of lifting 8 fully loaded Boeing 747 jumbo jets off the ground at once. Its maximum load moment, the true measure of a crane's power, is 88,000 ton-meters. Designed primarily for the precise and delicate work of third-generation nuclear power plant construction, this machine can hoist massive, prefabricated modules into place with surgical accuracy. It's a specialized tool for a very specific and very heavy job. But as impressive as it is, it's only the bronze medalist in this global competition. Taking the silver is a machine that held the world record for years, the XCMG XGC88000. This crane shattered expectations when it was unveiled, boasting a maximum lifting capacity of 4,000 metric tons, or just over 4,409 US tons. Its name comes from its incredible load moment of 88,000 ton-meters, a figure that pushed the boundaries of mobile crane engineering. In 2013, it made headlines by successfully hoisting a 2,155-ton propylene tower, a critical component in a petrochemical plant, to a height of over 360 feet. That single lift streamlined construction, likely saving the project significant time and costs compared to traditional methods. The XGC88000 is a true workhorse of China's energy sector, a symbol of the country's drive to build bigger, faster, and more efficiently. For a long time, it was the undisputed king, but there is one that goes even further. At the absolute pinnacle of crawler crane engineering sits the undisputed champion, the Sany SCC45000A. This machine is, simply put, the most powerful land-based crawler crane ever built. It boasts a mind-bending maximum lifting capacity of 4,500 metric tons, or a colossal 4,960 US tons. Its main boom can stretch up to 394 feet, and with a luffing jib, it can reach a total height of nearly 690 feet. The total counterweight needed to balance its heaviest lift exceeds 2,200 tons. Just mobilizing this crane to a job site is a monumental logistical operation, requiring a fleet of over 200 trucks to transport its components. This crane isn't just an evolution, it's a revolution, capable of lifts that redefine how megaprojects are planned and executed. These three machines are the undisputed heavyweights, and now that we've seen their power, the bigger question looms. How did one nation, in less than 2 decades, come to monopolize the very top of this highly specialized market? The answer has 2 parts, one driven by ambition and the other by pure industrial might. Super cranes like these aren't built for prestige. They're tools, and tools are only created when there is a job that needs doing. The story of why these cranes are Chinese is, first and foremost, a story of unprecedented domestic demand. Beginning in the early 2000s, China embarked on the largest and fastest industrial and urban expansion in human history. This wasn't just about building cities, it was about constructing a new foundation for the entire economy. A core part of this plan was a massive push into advanced energy and chemical production. This included a new generation of nuclear power plants, vast petrochemical refineries, and sprawling coal-to-liquid conversion facilities. These projects had one thing in common. They were being built using new, modular construction techniques. Instead of assembling massive structures piece by piece high in the air, entire sections, weighing thousands of tons, were prefabricated on the ground. This method is safer, faster, and results in higher quality construction. But it creates an enormous engineering challenge. How do you lift a 2,000-ton reactor vessel or a 4,000-ton distillation column into place? For years, the answer was to rely on foreign technology, primarily from established German and American manufacturers like Liebherr and Manitowoc. But this created a critical bottleneck. The availability of these specialized cranes was limited, their rental costs were astronomical, and relying on foreign tech put the timeline of nationally strategic projects in the hands of outsiders. This was an unacceptable vulnerability. If China was going to build at the pace and scale it envisioned, it couldn't wait in line for the right tools. It had to build them itself. This wasn't just a corporate decision, it was a national industrial strategy. The government, through its 5-year plans, identified super heavy lift capability as a key enabling technology. This shifted the entire equation. The goal was no longer just to build a crane. It was to achieve industrial self-sufficiency and eventually dominance. This is a pattern we see repeated across Chinese industry. Identify a critical domestic need, treat it as a matter of national importance, and pour immense resources into solving it. The demand for these cranes was born from China's own colossal ambition. But having the need is one thing. Developing the capability to meet it is another challenge entirely. So, China had the motivation. But how did companies like Sany and XCMG, relatively new players on the global stage, manage to leapfrog competitors with a century of experience? The answer lies in a unique industrial ecosystem that no other country can currently match. First is the sheer scale of China's heavy industrial base. To build a 4,500-ton capacity crane, you need vast quantities of high-tensile steel, massive casting and forging facilities, and a deep supply chain for everything from hydraulics to engine components. China is the world's largest steel producer, and its manufacturing sector is geared for projects of this magnitude. It's like trying to bake a cake, but your competitor owns the flour mill, the sugar plantation, and the chicken farm. The vertical integration and control over the entire supply chain dramatically reduced costs and development time. Second, this industrial base is backed by unwavering state support. These projects benefit from state-backed financing, prioritized access to resources, and massive investment in research and development. This allows for a long-term vision that isn't dictated by quarterly earnings reports. Western companies must justify high-cost R&D projects to shareholders looking for a quick return. Chinese companies, guided by national strategy, can invest for a decade to dominate a market for the next 50 years. Finally, there was a deliberate strategy of technological absorption and iteration. In the early days, Chinese engineers learned from the designs of established Western cranes. They mastered the fundamentals through joint ventures and licensing agreements with companies like Liebherr and Manitowoc, and in some cases, studied existing designs closely. But they didn't just copy. They learned, adapted, and then began to innovate. The immense number of domestic megaprojects gave them a real-world testing ground unlike anywhere else on Earth. While a Western crane might perform a handful of super heavy lifts in its lifetime, its Chinese counterpart often performs that many in a single year. This rapid cycle of design, build, test, and improve, fueled by relentless domestic demand, accelerated their expertise at an exponential rate. This created a self-reinforcing loop. Ambitious projects required bigger cranes, which spurred innovation. The resulting cranes enabled even more ambitious projects, creating a cycle that has left the rest of the world struggling to keep up. The massive lifts we spoke of at the beginning are more than just feats of engineering. They are the physical manifestation of a decades-long national strategy, a symbol of industrial ambition made real in thousands of tons of steel. This colossal lifting capability was forged to serve China's domestic needs, but it was never going to stay within its borders. The second act of this story is now unfolding on the world stage, and it represents a fundamental challenge to the established order of heavy industry. For decades, the ultra-heavy lift market was the exclusive domain of a handful of Western giants like Germany's Liebherr and America's Manitowoc. They competed, but they controlled the market. Now, they face state-backed competitors who can operate at a scale and price point that is incredibly difficult to match. This isn't just about selling a few cranes. It's about industrial competition on a global scale. The primary vehicle for this expansion is China's Belt and Road Initiative, a multi-trillion-dollar global infrastructure development strategy. As China finances and builds ports, bridges, and power plants across Asia, Africa, and the Middle East, it creates a captive market for its own machinery. When a nuclear power plant is built in Pakistan, like the Chashma nuclear power plant, or a megaport in Sri Lanka, like Hambantota, using Chinese financing, the contracts for the heavy equipment often go to Chinese firms like Sany and XCMG. This creates a powerful feedback loop. The more international projects they build, the more their cranes are seen and proven on a global stage, and the more their market share grows. This is more than just business. It's a form of industrial soft power. When you provide the tools that build another nation's critical infrastructure, you build a deep and lasting economic relationship. The global balance, which for a century saw the West as the primary source for the world's most advanced heavy machinery, is now being redrawn. The question is no longer if the established players can compete, but how they will adapt to a world where the biggest tools are now in someone else's hands. We've seen the three titans of lift: the SCC36000TM, the XGC88000, and the colossal SCC45000A. And we've uncovered the two key forces behind their origin: an explosion of domestic demand driven by national ambition, and a state-supported manufacturing ecosystem built for unparalleled scale. Thanks for watching Hard Hat Industries, your source for serious machines doing real work. If you like this, hit like, subscribe, and turn on notifications so you don't miss what's next. Until then, keep your head down and your gear running.